His name is Adrian Peret. He has worked in the telecoms industry for 20 years in various positions, covering both R&D and technical support, but also operations, hosting, data centers, and connectivity. And this experience allowed him to have a holistic view across multiple domains and their future impact across a wide range of industries. Currently working as Chief Architect Cloud in Nokia's mobile networks, he is focused on Edge Cloud, well, who isn't, and Cloud RAN and Telco Cloud Reference Architecture. Privately, Adrian likes scuba diving, or to be more precise, cave diving, and apparently, as of this year, he also likes code diving. So, let's give him a warm welcome. Adrian Peret.
Okay. Hello. Hello, everybody. Okay, so clear. Oh, that's a big screen. Adrian Peret is my name, and as you hear, I will say a few words about me. And guess what? Well, that's me in the red suit. Well, it's not. You don't see. I don't think you see it red, but the one in the left. That's me. That's a mine in Finland. It's a big mine with kilometers of places where you can go. And in the smallest picture in the left, you can see actually it's me, and the same pictures. Actually, I'm scootering through those mines in one of those tiny holes which you see there. And this is what I'm doing when I'm actually not working for Nokia. So that's my free time. And most of the time, I manage to get out and then continue working for Nokia. But I like it a lot. Of course, I do it when I can, but of course, I don't do it enough. I would like to cave dive more than actually I can do. So when I'm not doing that, actually, I'm working for Nokia. And I started in Nokia 20 years ago as a support engineer. So I'm an engineer. Now I'm a little bit undercover here with this kind of clothes. But I'm an engineer. And I started when I think most of you very young. So if you might remember the VML time, when internet was first time made available on the mobile devices, I think it was about 2000. And VML is now obsoleted. Just don't try to start learning it. It's useless. It was the time when the devices couldn't really process much, and HTML was too heavy for it, so it needed to be something more simpler and more lightweight. So then the VML came in picture. If you remember, the Nokia 7110, I think, was the first WAP phone at that time. So yeah, it's a long history. Then I moved to Saudi Arabia, of course, from Finland, where it's cold, where you would move to Saudi Arabia, 60 degrees plus. I was leading a team there, looking after Middle East and Africa on value-added services. In telecommunication, that means MMS, like mobile messaging, like VAP, internet, and so on. Then I moved to hosting. And hosting, it's basically, in Nokia, was a division which was giving very ahead of time data center and services, basically, as a service. It was very long time ago, 2008, so you can imagine when. Moved to many services, which what means in Nokia there is a division which actually operate other telecommunication providers' network. So we've been the one operating it in behalf of the actual operator. And in one point of time, actually, it's not well known, but Nokia was the second biggest operator in the world based on number of subscribers which we've been managing. Then I moved as a remote access solution chief architect, where what I looked at is connectivity. So connectivity across the world for our global delivery service centers. And then finally, I ended up in a current position where I look around telco IT cloud, basically. And why I'm listing all of this, first of all, you can see that I don't believe that you can learn something very fast and then have something very meaningful to say. So if you could see, I spent some time, all the time in one position except one of them where I've been only 8 months or something in the remote access solution. And the reason is that I believe that you need some time to be able to learn, and also you need to see everything from different points of view, not only one way. What I meant with this is that, for example, you have a car, which now we are saying, okay, the car with the combustion engines, they are polluting. So now, depending who you ask, you will get a different solution for it, because everybody has his own point of view. You are asking a teacher, they will say, it's all about education, it's all about teaching people and teaching the young generation that what needs to be done. You go and ask an engineer, he will say, okay, we remove the combustion engine, we put in it some batteries or hydrogen or something, electrical motors, that's how we solve the problem. You ask a politician, he will say, well, let's make some laws, regulation, So basically, you need to look at any object or anything, you need to look at it from different point of view, because it's not always, the solution that you think is right is not always obvious. So that's why I like to move around and try to be to know as little as possible for each domain where I move, so that at least I have something to learn about. Now let's talk about, I think, about what I'm coming here actually to talk. It's about the edge cloud. This is a very busy slide, which have so big numbers that I cannot even cope and process with my head. But what it's trying to say is that if you look at the industries, the digital industries, actually the annual productivity growth, it's bigger than actually the physical industries. And why did that happen? Because the digital industries were very easy to go in a digitized world. So they could very easy, you have a music, right? You have a DVDs. It was very easy to digitize them, have them MP3s, and then make them available online. You have books, okay, there was a physical book, you digitize it, then you can sell it, very easy. Well, you have a drilling machine. It's not that easy to digitize it. And even if you digitize it, you cannot make a digitized hole. So you really need to have a physical drilling machine, which make actually a physical hole. So those industries could not benefit from this digitization. And that's the whole reason that the physical industries, the annual productivity growth, it's smaller. What can be done about it? I think you hear about this Industry 4.0 revolution. So what does actually means? So in the first phase of the till today, basically what we did, we replaced the physical using digital. I was giving the examples of books, of music. These were very easy to replace, right? Now, what is actually Industry 4.0 bringing? Actually, it's bringing the capability to control the physical using digital. And that's the actual revolution where we are talking about. That's why we talk about Industry 4.0, which have a very big impact. But what is different? I think every one of you have some kind of IoT devices, some kind of automation at home, and or in any other way of doing it, using it. But the IoT, if you look at them, they are pretty simple, and their demands are also relatively they are not demanding. So basically, in the part where you see in, what is that color? I don't know what color you see there. Light blue, okay? In the light blue, it's the current IoT devices that we have. So if you have a air conditioning, you have a temperature device which measures your temperature. And then it will, based on some rules, you decide to turn on or off heating or air conditioning. You won't be bothered if the air conditioning starts after 5 minutes or 2 minutes. It's kind of fine. But then when you go to the industries, if your drilling machine starts 5 minutes later or stops 5 minutes later, that's not going to be good. It might be a too bigger hole. So what means is that in the past, the latency demands and bandwidth demands were limited, not so strict. Now in the Industry 4.0, there are two parts where demands is growing. We have a latency part where you have devices that you need to control, like robots, you can see in the bottom side. And then there is bandwidth, which it's required as well. and you have a 360 videos. And then, of course, when you need bandwidth and latency, then you end up in the upper right corner, like virtual reality. vRAN means virtualized radio access network, and plus vehicles and so on. So that's the biggest change, that all the gray part in this representation actually shows the difference. And that that kind of capabilities are needed to be able to actually enable and make that happen. Here is for the reference. Basically, it's service latency requirements in milliseconds. The green ones, which you see there, they are human response times. Just for the reference, there is a sprint start, 120 milliseconds. Well, I guess a good sprinter starts, not me. I might not react at all, okay? And then there is vestibulo-ocular reflex. I'm not a doctor, no clue. And I'm not an English speaker, you can guess, so hard to read. 7 milliseconds. What is vestibulo-ocular reflex? Basically, if I'm watching the gentlemen in the front row and I'm moving, and I'm still keeping the focus on them, that means it takes 7 milliseconds for the brain to react and move my eyes opposite head direction. And that means if that would not happen, actually I would not see anymore the person which I'm looking. It will all become blur. This is just for your reference. Now, the dark blue, it's maximum delay inside an application, okay, which is allowed for processing. You can see various examples, and then you have the maximum tolerance in the networking delay, which is the light blue. And you can see that starts to be very tricky, especially if it goes to things like electric grid control, Cloudify radio access network. You will see values like, for example, for the Cloudify RAN, we call it version 2.0, vRAN 2.0. I will not go into details from telecom side, but you need a 0.5 milliseconds maximum delay in transport. And then that's a little bit tricky because there are some laws, and there are laws of physics. And not much to be done about it unless somebody figure out how to accelerate the speed of light. Before that, we are stuck with it. So what means is that roughly 1 millisecond, if you want to have a round trip time of 1 millisecond, you cannot go further than 100 kilometers, because that's the speed of light propagation in optical fiber. And now if you want to have if you want to achieve a 1 millisecond latency, and where only the transport, it's already eating 0.5, then you have something left, which of course there is processing, right? In the source processing, in the destination, you might have some hops. So suddenly your distance, it's actually reduced to something like 30 kilometers in a cable length. So that's maximum what you can do if you want to achieve those latencies. And because of laws of physics and not much to be done about it, then something we need to do to, like a workaround. And that means we need to move the computing power, the computing capabilities closer to the actually source of data. And that means the current central, this is a very rough picture, so it's not really that black and white, but it's just representing the actual problem and solution for it. And some types of services cannot be provided unless the computing is moved, and we call them edge data centers. So centralizing things is not anymore possible if you want to achieve those capabilities. Okay. Of course, the edge cloud is basically pushing the limits to reach the next level. And actually, it's not only about latency. Latency it's one of the obvious problem. But there are other, because latency actually, you can see evolution of latency during a timeline. So it goes very low, and then there is a throughput which actually goes up. And what it means, the centralized data center actually were built as an efficient capacity, and they were driven by the laws of economics. When you centralize, you can easier operate, you can save cost by centralizing and by operating in a one place all your data center or your data center assets. But the edge data centers, actually, they are for low latency, efficient transport, and they are driven by the laws of physics. So we have a saying that you should centralize all that you can, and you should put on the edge only what is a must. Because having anything on the edge is pretty costly compared with a centralized one. Now, what is this all edge computing? Why it's so important? There are a big amount of, let's say, we call them kind of use cases that are basically driving this edge computing. One of it, of course, I'm coming from a telecom company, and of course, I will start mentioning the remote access network, the radio access network, cloudification, and evolution to 5G, which is one reason of it. Then we have fixed access network transformation. The fixed access network as well, they are driving towards transformation towards the edge cloud. Then there is latency, bandwidth, and security. They are very critical use cases in the IoT and MEC, which is multi-access edge computing. There are virtualized and distributed IP edge. Well, you can Google later on all those acronyms. You know, I'm coming from telco, and telco it's a funny word in the sense that it's always managed to invent all kind of new acronyms and new terminology for everything. So, for example, we are not saying application. When we put some application in the cloud, we are saying a VNF, which is a virtualized network function. For me, it's an application. It's a fancy name to say the same thing and sounds more, I don't know, more cool. But it's nothing else. A VNF, when you hear VNF, which is a virtual network function, is nothing else than yet another application. So nothing new there. By the way, I don't even remember all of these acronyms and what they mean. I mean, after a time of using them only as acronyms, you just really forget what is actually the original meaning on it. Then there is public, private cloud, and open ecosystem, and these are also driving all this edge. Now, when we ask somebody, okay, we talk about edge. What we mean with edge? For example, if you ask a car manufacturer and you say, what is your edge? Their answer will be, well, it's my infotainment inside the car. If you ask us as a telecom company, what is the edge, your edge that you are talking? Well, it's the last hop before the remote radio head, which remote radio head, for those which are not from telco, it's actually the antenna which you see on the poles or on the buildings which are your phone is connecting to it. So it depends who you ask, you will get a different answer. But what I'm trying to show here is when we say edge, when I'm saying edge, this is what I mean with that. So edge data centers, we are splitting them in two categories. You can see in the bottom side the description. One is a far edge, and the other one is an aggregated edge. And the split, it's basically done based on the way how the 5G cloudified radio access network is built. There is a component called VDU, which is virtualized distributed unit. And there is another component which sits on the far edge, and usually. And then there is a VCU, which is a virtualized central unit. And that sits usually on the aggregated edge. But what is important out of this is that the far edge sites, actually, here it's a very conservative number. We are talking about hundreds to thousands. Depends of the country, of course, because I was explaining before about the latency. So it's very depending on that. But in some countries, like North American countries as an example, you can reach tens of thousands, like 10,000 sites, 10,000 individual data centers to be able to fulfill those needs. In other countries like China, you can reach even 100,000 to be able to cover what is needed. And that's a very big number of a distributed equipment. Of course, the central data center, we split them in regional and central. It's a blurred line because usually a telco operator or any operator, they not really have one central data center. They usually have 2 or 3 for geo-redundancy reasons, which they all together, they consider them central. So it's a very, again, a blurred line. Is it regional, is it central, and so on. But what is important, it's about the far edge and aggregated edge, which is in the number of thousands. Before going to go in more detail on it, just to be clear, there is all this kind of idea that any application must be able to run on any infrastructure. And yes, that's a great sentence, but it's not exactly like in the movie. So there are some differences. So let's look as a timeline here, and let's think that in the upper side, we talk about application. In the lower side, we talk about infrastructure. And guess what? Here are the applications. 1920s, that's how a car looked. And of course, that's how a road looked, right? All fine. That car was running perfectly on that road. Now I have improved cars. I guess you guess what car is that. It's a Lada. Or actually, it's a Fiat, if I remember well, the origins of it. Then, of course, the infrastructure, right, which are the roads, they improved as well. And then goes on and on. Application improved, better application, better roads. And now the future, we don't know what car we'll get. We don't know what infrastructure we'll get. Now, if we are expecting that the car from the upper right side, so the application from the upper right side, we run at the full power, full performance on the infrastructure, which is in a dirt road on the left side, that's going to be tricky. So you cannot have a Formula One car running on a dirt road and then obtain full capabilities on it, full performance on it. And that means you cannot run a running cloud native telco application on a traditional cloud infra. It's like driving a modern fast car on a dirt road. So what means is that in the same time when application evolves, the infrastructure needs to evolve. And when I'm saying infrastructure, again, because I've been looking to other speeches here, and I realized that also infrastructure, it's a very relative term. So when I say infrastructure, I mean hardware and the cloud infrastructure which sits on top to provide you services where you can put your application. That's what I'm saying when I'm saying infrastructure. Now, what are the challenges with the edge data centers? So first of all, they are remote sites which have limited space and power. I give examples. So limited space, you are not anymore in a real data centers where you have a very defined space and you can expand, well, theoretically in a easy when you want to scaling in or you want to put something in. In an edge data center, you might have a very limited space, including the dimension of it. Like for example, in the telco cases, most of them are only 600 millimeter in depth, and it has, for example, a maximum power allowed to be 2.4 kilowatts. So when you have maximum 2.4 kilowatts and you have a constraints on the size, then okay, that's one problem already. Data center hardware, it's not actually built to be used in those edge use cases. The cloud infrastructure itself, it's not built usually to run on a very small environment. It's not easy to deploy a cloud in one server or deploy a cloud on a laptop like I have here. Then the management of it is not exactly easy to manage thousands of small clouds. You need to do something about it because definitely you cannot go and if you need to change a password and you have 100 edge sites, 100 clouds, and it takes you 1 minute to change a password, it will take you 100 minutes to change a password in 100 sites. So that's not exactly the best job that you would like to have. Of course, proprietary solutions usually. Now, I will actually go in more details in actually requirements. So I was explaining what are actually the problem generated by this, and now that have some requirements. And I will, of course, read all of them and talk about them. No, I'm just kidding. There is a big list and you can read later on. But I will actually point out the most important ones. Of course, openness. It's very important to have, especially in an edge site, you must be able to deploy open hardware because that allows you to modularity, that you can accommodate inside the same chassis, inside the same equipment, different components. So you don't need to change everything because now you need some additional equipment there. It needs to be, of course, energy efficient, but then there is one very important which you might be noticing or not. There is one sentence called vanity-free design. And that was for me first time when I seen it. I'm like, whoa, what is that? Of course, not English speaker. I have no clue what that means. And actually, it's quite cool, but it's very nicely formulated as a vanity-free design. Means that there should be no extra piece built there that have no purpose. Means don't make your hardware to look good by putting labels and additional plastic which have absolutely no meaning except to look nice. That's what vanity-free design means. Of course, I mentioned the 2.4 kilowatts. And of course, telecommunication, if you want to use this edge data center for telecommunication purposes, there are some other standards which you need to comply with. And one is these NEBs. So they need to be built in such a way they are resistant to, for example, earthquake and so on. Now, as an example here, that is a, of course, I couldn't come with other example that from Nokia. So that picture which you see, it's called iframe Open Edge, and that actually allows you to deploy 5 servers in one chassis in a very tight setup, which is only 600 millimeter depth. So actually, you can replace old telco equipment and then just replace it with this one, and you can have your edge cloud by reutilizing your facilities which you have before. Now, let's talk about the cloud infrastructure. Because, okay, you have the hardware, great. But if my hardware, it cannot be deployed in my cloud infrastructure cannot be deployed on a small footprint, or it's not providing a certain capabilities, then that's not going to be exactly useful. So there are a set of requirements which comes to the cloud infrastructure to be able to actually deploy such a thing on the edge. Of course, there is again a very long list of things which need to be done, but I will go to some very important ones. So it needs to be able to do fast recovery. What we mean with fast recovery means that it needs to be able to detect a failure in a components of the infrastructure and do an action to fix it in a very short period of time. Actually, it must be below 1 millisecond. And let's give an example. If you take available solutions, and they are using, for example, corosync and pacemaker, and that is taking about 8 milliseconds to actually detect a failure. Now, if your budget, before you can declare a call dropped, it's 1 millisecond, but your infrastructure detects a failure and take an action in 8. So, you know, there is a problem. So you need to do something about, so the old way, it doesn't really work. And that's why it's very important to actually detect the failure in the equipment, including disks, networking, memory, or any component there. You need to detect it basically in less than 1 millisecond. The best would be about 0.5 milliseconds, so that you have 0.5 millisecond time to actually do some actions, like migrating some workloads, and do something that actually the call it's not dropped. When you have a distributed site, so you have hundreds or thousands of sites, you don't want to visit them. So what it means is that the whole infrastructure must be able to be deployed, must be able to be maintained, so lifecycle management of it must be able to be done via well-defined APIs. You don't want to climb the pole and go 20, 30 meters from the ground just that you need to upgrade your KVM. That's not going to be really cost effective. Then, about lifecycle management. So, because the resources are so limited, you have a very small cloud, even that we still call it a data center, but you know, it's like few servers. You can have 5 servers, like an example. You need to be able to do all this operation. All the lifecycle management must be possible to be done without disrupting the running workloads. So That's extremely important because you don't want your call to be dropped. You don't want your data to not work just because now I'm doing maintenance. You need to be able to do seamless upgrades, seamless downgrades, seamless scale in, scale out. That should not be seen by the applications that run on top. Very important, it's needed to be, we talk about cloud native and we talk about containers, but in reality, there are still many applications which they are not yet, let's say, truly cloud native, and some of them they still use virtualized environment, virtual machines to actually run. So on the edge cloud, because it's such a small footprint, you must be able to deploy both kind of workloads. You must be able to deploy VM-based or also container-based, and I'm talking bare metal. Because deploying a container inside a virtual machine, that's not really efficient. So they must support, we call it hybrid integration. So they must have KVM and Docker, and then of course they should be able to, they should have OpenStack and Kubernetes as an example, all under the same management. So you see as a one unified infrastructure. Of course, there was a lot of discussion on security. So yes, they need to be secure, and I'm just putting some question on it because you need to, because now all the sites are remotely. So when you do deployment, so how do you know that the hardware that you deploy there, it's your hardware? How do you know that actually the firmware which is inside those equipment, is it actually your firmware? So how do you know that when you deploy an application on a certain edge, how do you ensure that is that edge actually in the location which I'm actually expecting to be? How do I know that my application actually wasn't tampered in transit? So there are a lot of things which need to be taken care of when you distribute your workloads, especially in locations which are not exactly security proof, because they can be a cabinet in some shop or in a factory, or they are not in a very tight with the high security data centers like the central data centers. I mean, if you try to go to a Google data centers, it's not exactly easy to jump the fence and run around. But if the whole edge is in a closet behind the stairs, then not much security there. And then we go to the management and automation. So again, imagine that what is happening today. You have a hardware and you have a software. Now, you want to upgrade the KVM as an example. And what is happening, the infrastructure guys come and said, okay, let's upgrade the KVM, and then the procedure starts, and then the whole system comes back telling, well, the firmware which sits on this hardware actually is not the right one, so we don't upgrade. And what is happening, that team goes to the hardware team, talk with them, hey, go and upgrade the firmware, and then when you are done, let me know. And this is absolutely unacceptable, again, when you have such a distribution of sites. When you have hundreds or thousands of sites, that is unacceptable, and it is extremely slow. So what means is that it must be a way that when you trigger an upgrade of the KVM, you must be able to, okay, check firmware is wrong, okay, then you should be able to do a query to the hardware management solution that will actually put that particular server in a maintenance mode, migrate all the workloads to a different running server, do the upgrade of the software. Once it's done, inform the cloud infrastructure that, okay, in this case, the Unified Cloud Infrastructure Management, that, okay, now it's done. Please continue your KVM upgrade, and so on. And that's the way how all of this should be done and can be done in a very automatized way. Now, some use cases. So, okay, I've been talking a lot of what are the problems in it, what are the requirements, but now what is all this used for? Well, what is this edge cloud, and why do we really actually in practice we need it? So there are a few examples which I will cover here. This is called enhanced maintenance. What does it mean? Basically, you can have all kinds of devices that you can use, like smart goggles or even a tablet or anything that actually can show you what you would actually supposed to do without the need that you go to some manual and you read about them and then you do the action. So basically it is showing you with augmented reality exactly what is next step that you should do to do a certain maintenance procedure for a certain equipment, identifying it immediately. So all this data from sensors and all this content, this is actually preloaded in an edge cloud because the reaction time, especially on the augmented reality case, need to be very fast. You cannot, if you take all the data and you put it to some centralized data center, meanwhile the latency will be too low and then it's kind of unusable. Video analytics for smart manufacturing. We have actually, you can search the YouTube. There is in our factory in Oulu, in Finland, we use already 5G in cooperation with the local operators, and we use it for quality control in the factory. So basically there is an edge cloud and the 5G network which is automatically analyzing the video feed from the people which actually does the building things there, and it is following up if they are doing the correct steps in the correct order and triggering immediately if something it's not right. That's one way to use it, and it's required to be actually in the real time. And I think in the left, the picture in the left, actually it's from our factory, where is a technician. You can see it's moving screwdriver, and it needs to be done in a certain pattern, in a certain order, tightening of those screws. And that's with the video camera on top, it's actually following the pattern if the technician does the action in the correct order, and then to validate on the quality of the execution. Edge video orchestration. So basically you go to a stadium, and of course you can see live what is happening there, but there are many other cameras, many other angles where you can actually, all this event, it's presented. So what you can do, because now the content is required to be processed, captured, processed and distributed, broadcasted locally, only to those which are on the stadium. Again, you have an edge cloud there in the stadium, which is taking all this data, it is processing all the video information and then making it available to the people. They can see, rewind, they can see from different angles the same game, even that they are sitting physically only in one position. And that is also, it's in use, you can see here in the, I think the left and the middle, it was used in some operator in the Middle East. And then the right side was with Formula 1, actually, event, where it was used exactly for this purpose. Video analytics for public safety. So again, this is another part where there is a lot of usage on this one, because you have a huge amount of data. So think about it. If there is a security guard which sits in front of screens, okay, and then sees a person, like is that there in the picture, there is a person sitting near a fence. Because you move between different screens, what you can say, okay, there is a person near the fence, what it does, he did he smoke a cigarette, or what did he did there? You really, it's very hard to see the actual, what was actually the cause of that particular person being there. So, but if you have all this content locally in an edge cloud, you can do some analytics on it to actually figure out the pattern of that particular person movement, and then trigger another, which in this example, that particular guy actually was jumping the fence. So then you know that, okay, this is not there by mistake, he actually jumped that fence, and you can trigger some events based on that. Of course, recognition of face recognition, people counting, and all the other video analytics use cases are as equally valid. And then we talk about connected cars. So this is the part where latency is extremely important, because if you want to have features like platooning, I don't know if you are aware of this. Platooning means that you have a selection of multiple cars which they start to talk to each other and drive side by side very very close by, because they are all controlling each other. So if the car in the front of the platoon breaks, it is immediately all the rest will break. So without the need to keep that normal distance, which we are keeping now, because there is a reaction time till you figure out the guy in front is braking now, I should brake as well. So in these cases, the latency is very important, because you can imagine that, well, if the information from the first car is sent with a little bit later to the next car or the last car, then things will not go exactly as planned. So these are only very little set of use cases which are drivers for these edge cloud deployments. I was presenting a lot of requirements on it, a lot of challenges about it. But what is important is that it's unavoidable. So we like it or not, the edge cloud, is it here, will be here. You can see in the left side, there are many public available papers where it's describing various organizations, how they plan to deploy the edge clouds. For example, in the upper left corner, there is China Mobile, which is showing that they will deploy about 100,000 edge clouds. There are Gartners, which are analysts explaining how this is done. You have their AT&T and other operators which are clearly planning this future. And then on the right side, there are open initiatives where actually Nokia is also part of most of them, where also software is developed to be able to, not only software, but also the hardware, it's developed in such a way that allows these edge cloud deployments. For example, the hardware which I just showed to you from Nokia, actually, it is built by Nokia, but Nokia upstream to OCP, Open Compute Projects, all the design. So now anybody, and it was accepted there, so anybody can build now equipment based on that design. So we don't want to keep it in-house. So we consider that upstreaming it and making it open source, it's actually a key to success here. Some takeaways out of this. So HDCs, they are clearly needed to provide low latency, high throughput, and privacy. There is no other way around. If you need any of these, only one of these characteristics, or all of them, it's kind of unavoidable. So you would need to have, in one way or another, an edge cloud. Of course, can be small one, like I explained, with only few servers, but you can have also a big edge cloud. Like you take a factory, it might have like few racks of equipment, which is still classified as a edge cloud, because just sits in their premises for whatever reason. Privacy, one reason, latency, of course, and then throughput. Converged access, what that means is that having these edge clouds allow you to have a converged access, means wireless and fixed. They will both converge in the edge, from where basically you can have all kinds of services. Everybody will have possibility to get all services from one point, which currently is not exactly possible. And what is the last but the very important part, without automation, I'm actually calling it extreme automation. This is not going to happen, because it's not feasible to do anything manually. So all must be fully automatized, especially when all of these are distributed. So there is no other way to achieve this only by automation. And basically from everybody else, you need to to look at it, that this will happen. And of course, it's up to everybody and all of you here to figure out what wonderful services or something can come and can be built based on this, with the use of these capabilities. So this will come, and then of course nobody can, at least I cannot figure out what kind of services you can build. So I guess, as a given example, there is in Finland, there is a application which actually allows you to figure out if you can catch the train or not. So it was made by a person which actually he built it for his wife, because his wife was never able to not always catching the train. And knowing when the train comes is not exactly, you know, it's a schedule, but in reality it's not sure that it will be there. It could be 2 minutes later, 2 minutes earlier. But the Finnish train system exposed the APIs where you can actually look where is the train actually, the location of the actual train. And he used it in combination from mobile data from the operator, which also exposed it, plus the GPS location of the phone. And then it could give you the idea that, okay, now if you run a little bit faster, you will actually catch the train. And it's one of the very popular application there. And I can tell you, I would not even think to do it. So there is always somebody can figure it out some ways, combining all of this, which you will not even think about it. And Edge, it's also one piece where might be some services coming out, very wonderful services out of it. So you can run, but you can hide from it. The Edge Cloud is here now. That's all what I have. Thank you. Yeah, questions, actually.
Yes, please, questions. So if anybody's interested, the stairs are here for you, and so is the mic. Anything about catching trains?
Okay. Who? No question. Oh, okay, there is a question.
Thank you for your wonderful talk. I have actually a couple of questions. So I was wondering, do this infrastructure on the edge infrastructure requires real-time operating systems already to achieve? Okay.
Yes. So if you need real-time capabilities on infrastructure.
Yeah, I was wondering a little bit more on the software side.
Yes. So yes. Okay. So actually, one of that very big list which I was showing in the infrastructure, one of the items is real time. And when we talk real time, we are saying that I will give you value. So between from VM to VM communication inside the same CPU, it must be below 50 microseconds. Microseconds, not milliseconds. So yes, there is a need to have real-time communication to be able to deploy telecommunication equipment on it. Yes, it is needed, and it's mandatory, basically.
Yeah. And you mentioned at the beginning that you started a career as a senior engineer at Nokia. And I was wondering, do you miss anything from being a software engineer nowadays?
So I didn't start as senior engineer. That was how I finished that position. I started as the official name was product expert. And it was a funny name because when I came there, how can I be expert in my first day, which I don't know anything about anything, so how can I be expert? But that was the position name. It evolved during 6 or 7 years, and then I finished it as a senior engineer. So no, I don't miss it. Why? Because I'm running on my laptop our own cloud infrastructure in a virtual machine. So I do at home a lot of programming. So I try to not disconnect myself from doing real things. So yes, I know nowadays I'm calling myself PowerPoint paper pusher. Okay, I do a lot of paper pushing around, but I try to also do real things, because talking about things is one thing, but when you do it yourself, you learn a lot. So yes, I'm missing it, but I'm not missing it because I'm continuing doing it. Don't be fooled. So this is just a show off. So no, I'm doing still real work, not only paper.
Thank you.
Thank you very much. Any more questions, please? Yes, there's one over there.
Hey, I have a question, maybe a little more explanation. At the beginning, I understand this talk is about how it is done in Nokia in base towers and some sort of this approach, like big company have multiple edges to cover and provide software there to perform some action like communication with mobiles and etc. And later I understand that when you talk about stadium use case, for example, where there is dedicated on-premise their server for video streaming processing and sort of this functionality, And in between, I didn't catch, maybe, did you suggest that there will be some sort of general purpose edge computing node for everybody use? But again, I think on the other side there is some dedicated on-premise servers which don't have use outside this specific location, for example. So why we need general purpose on-premise, on edge computing solutions? So maybe I didn't catch this, but it's my question.
Okay, so first of all, I'm not from marketing, so I didn't come and tell you how wonderful the Nokia stuff is. So my intent wasn't that. I just give you examples of Nokia equipment because I don't know what other examples to give you. So that's why I didn't talk. I talk about, requirements in general, how they are fulfilled, and so on. So now, when it comes to the infrastructure for dedicated those use cases, that infrastructure is not built for that purpose. So the infrastructure which is deployed in a stadium, it's a infrastructure which I was telling you that is it need to be optimized, means that it need to fit on a small footprint, but it provides you all the capabilities which you get from a vanilla OpenStack or vanilla Kubernetes, so you can deploy any application you want as long as your application can deal with the vanilla APIs which are available from an OpenStack or Kubernetes infrastructure. So it's not purpose-built, and that's the whole point why we consider the edge, it doesn't make economically sense if it's built purposely for only one use case. The economy, so how can we, the TCO will go down, the total cost of ownership will go down if you use the edge for multiple use cases. So if in that stadium, for example, there is one of the use cases is that stadium, nobody is stopping, and actually you should be able to deploy, for example, the RAN part, the remote access, radio access network components of a 5G, that is one application. You put it on the same infrastructure on that stadium. Then you deploy on it, for example, the controlling part of a fixed network. You put it also there. You want to put your nice application, which is doing statistics based on people movement on the stadium. You deploy that one as well there. Of course, you need to have capacity to put all of this, because it's not, the cloud is not infinite, how somebody might think of. But no, it's not purpose-built. So that was a very good question, and good that actually I could say it.
So this, as far as I understand about, after you explain this is some sort computing center which is general purpose, and you can reuse it in your place without any customization, because one vendor, other vendor is like open source data center which you can bring in case and put everywhere.
Correct.
Okay, so
yes.
That's
the idea. Of course, it's not. Of course, you won't find it. I mean, somebody need to build it, somebody need to provide it, and somebody definitely will charge you for it. But in the end, yes, it's multi-purpose built solution, and that's how it should be. Yep.
Hello. My question, I think you answered it almost, but because you mentioned OpenStack and Kubernetes again when you were answering this question, but I'm wondering whether you believe these are the best tools to use also in this edge cloud, edge computing, or maybe are there some better orchestration systems that are more suited specifically to be used in edge computing instead of generic clouds used everywhere else, especially also when we consider that maybe we would want to run this as a single node application, maybe we don't need all of those orchestration systems. What would you use then?
Okay, so now I will talk about what we did. Okay, so I will talk from Nokia point of view. So we consider that, first of all, OpenStack, Kubernetes, KVM, and Docker, they are the mostly used, right? So we decided that, okay, you need to make a choice. You cannot make it from everything. So we made a choice. Do you want to deploy VMs? Then we provide you capabilities to deploy VMs on a KVM with OpenStack as a management, and the OpenStack will provide you vanilla API. So you don't need to we don't build some specialized APIs. All it's open source, and we don't build specialized APIs because nobody will use them, right? The Kubernetes is the same way. We consider that this is the mostly used, and this is what we use. What we did with both of these, we optimize them in the way that actually you can have in one server, you can have your, of course, you cannot have in one server currently running KVM and Docker in the same time because there is a resource allocation problem. So if you have 5 servers, you can say, okay, 3 of them I'm dedicated for KVM, 2 of them for Docker. And what we did, we actually built what is missing out of the whole community out. We built a middleware system which provide enhancements to what is missing. Optimization, lifecycle management APIs, which are missing completely from OpenStack or Kubernetes, and all real-time optimization in the KVM and so on. So we took all these available open source components and we optimize them, and then we build separately, we call it middleware, which allows us to deploy Telco. Is it good or bad? You are asking, is it something else? It's not us to decide. It is community who decide what is it. So if community runs on, wants to have Kubernetes and OpenStack, then be it, there it is. It's not us really to decide. What we only could do is to optimize it, that's it.
Lovely, thank you very much for your questions. And Adrian, we wish you in the future, thanking for your great talk, safe scuba diving, safe cave diving, and very successful, hopefully in the future, code diving as well.
Yes, yes, thank you.
Adrian Peret.
Thank you.